Welcome to The Explainer. This is where we take big, complex ideas and, well, we break them down. Today, we're diving into something called clustering. It's this super powerful way of finding hidden groups in data, basically turning a mess of raw numbers into a real, actionable strategy. Okay, let's start with a problem I think we've all experienced. You ever get an ad or a marketing email and just think, why? Why on earth would I want this? It's totally irrelevant. Well, that happens because businesses often have no clue who their customers really are. And that leads to marketing that just completely, totally misses the mark. And believe me, the cost of getting it wrong, it's huge. I mean, look at the difference here between guessing and actually knowing your customers. It affects everything: sales, customer loyalty, you name it. So, what's the solution? Well, it's pretty simple. Stop treating everyone the same. You've got to find the natural groups, the tribes, that are already sitting there in your customer base. And that, right there, is the whole idea behind clustering. It's what we call an unsupervised learning technique. Now, that sounds fancy, but all it really means is that we're not telling the computer what to look for. We're not giving it pre-made boxes to sort things into. Instead, we're just saying, hey, look at all this data. Find the natural groups for me. Find the tribes. It's all about discovery. Okay, let's really get into it. But that brings up a really good question, right? How does a computer even measure something like similarity or closeness? I mean, a machine can't just eyeball it and say, yeah, those two look kind of similar. It needs a hard mathematical way to measure how close two things are. And that's where something called distance metrics comes into play.
And what's so cool is that there isn't just one way to measure distance. Think about it like this. You got Manhattan distance, which is like a taxi in a city. It has to follow the grid, right? It can only go block by block. Then you have Euclidean distance, which is more like as the crow flies, just a straight line from point A to point B. And which one you use? Well, it totally depends on the kind of problem you're trying to solve.
Okay, but hold on. There's a catch. A big one. If we just jump in and start calculating distances, we're going to run into a huge problem. Imagine you're comparing someone's income, which is in the tens of thousands, to the number of purchases they've made, which might be like 5. The giant income number is just going to completely dominate the calculation. It's going to make those smaller but maybe more important numbers totally irrelevant. The whole analysis becomes skewed. Basically, it's meaningless. So, how do we fix this? How do we level the playing field? Well, there's this really elegant solution called z-score scaling. It's a simple but incredibly powerful trick. What it does is it puts every single variable onto the same standardized scale. It's like converting everything to the same currency. This is absolutely crucial because now a big change in income is weighted just as fairly as a change in how many times someone buys something. Everything gets a fair shake. All right, so our data is prepped, it's clean, and we can measure distance fairly. Now for the fun part, how do we actually find the clusters? Let's talk about one of the most popular, most famous algorithms for this: K-means. The way K-means works is actually pretty cool. You can think of it like a dance. First, the algorithm just randomly drops a few starting points into our data. We call these centroids. Step 2, every single data point gets assigned to whichever centroid is closest to it. Then, step 3, the centroids themselves move. They move to the average location of all the points that were just assigned to them. And then you just repeat that over and over. Assign, move, assign, move. It keeps going until the centroids stop moving, and we're left with these really stable, well-defined clusters. It's amazing, really. It's how the machine literally learns the structure hidden in the data.
But there's a question, a big one. The K in K-means stands for the number of clusters. And we have to tell the algorithm how many clusters to look for. Is it 2 groups, 5, 50? This is a huge deal because if you pick the wrong number, your results are pretty much useless. So how in the world do you pick the right K?
Thankfully, there's a really clever trick for this called the elbow method. What you do is you run the K-means algorithm multiple times, once with 2 clusters, then 3, then 4, and so on. And for each run, you calculate a score that basically tells you how tight and well-defined the clusters are. When you plot this out, you see the score gets better and better really fast, but then it starts to flatten out. The benefit of adding one more cluster just isn't that big anymore. And that spot right where the curve bends, that looks like an elbow, that's our sweet spot. That's the best K.
Okay, so this all makes perfect sense when you can see your data on a nice, simple 2-dimensional chart. But let's be real.
Real-world data is way more complex than that. It's high-dimensional. We might be looking at customers based on their age, income, location, last purchase date, browsing time. You could have 10, 20, even hundreds of different attributes. How can you possibly see clusters in that? You can't draw a 20-dimensional graph.
This is where we bring in the big guns. And it has a crazy name, I'll admit, but just stick with me. TSNE. The best way to think about TSNE is like a magical map maker. It's this brilliant algorithm that can take all that messy, high-dimensional data, all 20 of those attributes, and cleverly flatten it down onto a simple 2D map, a map that our human eyes can actually look at and understand. It lets us finally see the clusters. So what's the goal here? The whole point of TSNE is to make sure that points that were close together in that complex 20-dimensional space are still close together on our new 2D map. It preserves the local neighborhoods, if that makes sense. That's why it's so perfect for this kind of thing. It's designed to make clusters pop out visually, so we can actually trust the patterns we're seeing on the screen. Okay, so now we have this gorgeous map from TSNE showing us all our different customer tribes. But a map is pretty useless if you don't have a legend, right? It's just a bunch of dots. This is where we go from just finding the groups to really understanding them. And this step, my friends, is where the real gold is. It's called cluster profiling. What we do is we look inside each cluster and ask, who are these people? We look at their average income, their average spending, what they like to buy, and based on that, we can give them actual names, create real personas. Suddenly, they're not just cluster 1 and cluster 2 anymore. They're high earners, bargain hunters, and mid-tier tasters. We're turning abstract data points into a story we can understand. And this is why all that work matters, because now you have a strategic playbook. It becomes so obvious what to do next. You send your premium high-end wine offers to the higher earners, you send discount codes and special deals to the bargain hunters, and for those reliable mid-tier tasters, you create a loyalty program to keep them coming back. It's all about targeted, precise action, instead of just guessing. So, when you boil it all down, what's the big takeaway? Clustering is the bridge. It connects that raw, messy data to smart, actionable business strategy. It's how you go from a spreadsheet full of numbers to a real playbook for growth. It's the difference between flying blind and having a crystal clear roadmap. And look, this idea isn't just for marketing. It applies absolutely everywhere. Finance, medical research, even city planning. Anytime you've got complex data, I guarantee there are hidden groups and patterns just waiting to be discovered. Which leaves us with a pretty exciting question to think about. Thanks so much for joining me for this explainer.